Very quickly, let's go over the homework that I gave you. It was on equations involving absolute values, but I'm sure you know if what you did is correct or not, because you can always substitute it back. That's a good thing about equations. When you get an answer, you can always check and see if the answer is correct by substituting it back into the equation. If it doesn't work and it is not invalid, then maybe you need to check your calculations and the way that you did them. Right, so I did the odd numbered questions yesterday. Today for the homework, look at the even numbered questions. This was exercise 4.1.2. I've seen these are available on e-learning, so please make sure you download them so that you can follow what I am doing. Then number 2, this was absolute value of 3 minus x. This is equal to 0. Now, when this is equal to 0, we don't do it any differently. What we do is you can still say 3 minus x is equal to 0, and then that's positive 0 if you like, and is equal to negative 0. But positive and negative 0 are exactly the same, so you'll only end up with one equation. So you can write it the way I said, positive 0, negative 0, but again, you will only end up with one equation. Okay, just give me a minute. Okay, so solving this one, I will get x is equal to 3. Okay, so again, you always need to check. So with your check, you have absolute value of 3 minus x, and this is, sorry, not 0. 3 minus 3, this is absolute value of 0, and this is equal to 0 because 0 is 0 units away from itself. It is at 0, so the distance to 0 is 0. Okay, and this was my left-hand side. Then the right-hand side, this is just 0. So because my left-hand side is equal to my right-hand side, x, which is equal to 3, is a solution. Okay, so that's how you would solve that one. So this one has only one solution. Then number 4, this is absolute value of 3x plus 2. This is equal to 2 minus x. Okay, so we do this one in the same way. We say 3x plus 2. This is equal to positive of what I have on the right-hand side, and it is also equal to negative of what I have on the right-hand side. So remember, the brackets are important to show that the entire thing is negative. So it's this 2 minus x that is negative, not just the 2. Because if my brackets are missing, then brackets are missing like that, only the 2 is negative, and that's not correct. So now you have two equations, you solve them. So here I have 3x plus 2. This is equal to 2 minus x. So what I can do is add x on both sides. So I will have 4x on the left-hand side. And then Hold on, somebody's joining in. Okay, so again, all of you have a NUST email that you can use to log in. So if you log in with that one, you don't log in as a guest, and then I won't have to admit you. It's automatic. So as much as possible, please try and use your NUST login details. And then if I subtract 2 on both sides, I will end up with 0. And this means that x is equal to 0. Okay, and then the second equation, I have 3x plus 2. This is equal to negative of 2 minus x. Then I will multiply the negative out. Remember, it must multiply everything in. So I have 3x plus 2. This is equal to minus 2 plus x. And then I will subtract x on both sides. I will end up with 2x. And then if I subtract 2 on both sides, I get minus 4. Then I will have x is equal to negative 2. Okay, so these are my two solutions. As usual, I need to check and see if they are indeed valid. So to check, okay, so I start with x is equal to 0. So on the left hand side, I have absolute value of 3 times 0 plus 2. This is just equal to absolute value of 2. And absolute value of 2 is just equal to 2 because 2 is 2 units away from 0. Then on the right hand side, I have 2 minus x, which is 0, and this is just 2. Okay, then I compare what I have on the right hand side with what I have on the left hand side. These two are equal, and then I can conclude since the left hand side is equal to my right hand side, x, which is equal to 0, is a solution. Okay, so that one is checked. And then I move on to the next one. X is equal to minus 2. So I need to check if this is valid or not. So I will substitute it on the left hand side. When I substitute it on the left hand side, I have absolute value of 3 times minus 2, 3 times x, and then plus 2. Then you simplify what you have inside the square root. This is absolute value of minus 6 plus 2. This is absolute value of minus 4. And this is just equal to 4 because minus 4 is 4 units away from 0. And then on the right hand side, I have 2 minus the value of x. X is minus 2. So I have 2 minus negative 2. This is just equal to 4. So my left hand side and my right hand side are equal. Then I can conclude. Therefore, x, which is minus 2, is indeed a solution. Okay, so that was that one. Let's do the next one. That was number 4. Number 6, we have 2 absolute value of x minus 1. This is equal to 8. So here, remember what I said, you must have absolute value isolated on one side, everything else on the other side. So the first thing you need to do is divide by 2 on both sides. Divide by 2, divide by 2. You get absolute value of x minus 1. This is equal to 4. Now in this form, I'm sure you know what to do. You will say x minus 1 is equal to 4. Or x minus 1 is equal to minus 4. And then you solve the first one. So I have x minus 1 is equal to 4. So this means that x is equal to 5. So I add 1 on both sides. So that's the first one. And the second one, I have x minus 1 is equal to minus 4. You add 1 on both sides. I will get x is equal to negative 3. So these are my two solutions. Again, I must always check. Substitute it on the left-hand side, substitute on the right-hand side, and then see if what I got satisfies the equation. So on the left-hand side, I had 2 multiplied by the absolute value of, I'll start with 5. Okay, so this is just 2 times the absolute value of 4. This is just 2 times 4 because the absolute value of 4 is equal to 4. 4 is 4 units away from 0. And this is equal to 8. And then on the right hand side, I didn't label it. Okay, then on the right hand side, I have 8. There's nothing to work out there. Then I look, my left hand side and my right hand side are equal. Then I make a conclusion, x equal to 5 is a solution. That's it. Then I have to check the other one, which was x is equal to minus 3. I have x is equal to minus 3. I substituted on the left hand side. I have 2 times the absolute value of minus 3 minus 1. This is 2 times the absolute value of minus 4. So when the number is next to absolute value signs like that, it means it's multiplying. Okay, and this is just 2 times 4 because absolute value of negative 4 is 4 because negative 4 is 4 units away from 0, except it's just on the left hand side of 0. Okay, and then this is equal to 8, and we know that our right hand side, this is just equal to 8. Again, these two are equal. All right. Therefore, x, which is equal to minus 3, is a solution. And then the last one, we have, this was number 8, we have 3x is equal to the absolute value of 7x minus 2 plus 5. So again, we have to isolate the absolute value, put it on one side by itself, and everything else on the other side. So I have absolute value of 7x minus 2. This is equal to 3x minus 5. Okay, and then we proceed in the normal way. We say 7x minus 2. This is equal to 3x minus 5, or 7x minus 2. This is equal to negative 3x minus 5. Okay, then you have two equations that you need to solve. Starting with the first one, we have 7x minus 2. This is 3x minus 5. You can subtract 3x on both sides. You'll end up with 4x on the left-hand side. And then you can add 2 on both sides. Then you will end up with negative 3 on the other side, on the right-hand side. Then you want to solve for x, so you'll have x is equal to negative 3 over 4. So this is your first solution. And then the second equation, we have 7x minus 2. This is equal to minus 3x minus 3x minus 5. Okay, so the -1 here should multiply everything in there to get 7x minus 2. This is equal to minus 3x plus 15. Why 15? Plus 5. Okay, I think now I've multiplied it correctly. Then what you do is you will add 3x on both sides. So you will have 10x. And then you will add 2 on both sides. You get 7, and that means x is equal to 7 over 10. So now I have my two values, and as usual, I need to check and see if they are both valid. Okay, so I will start with x is equal to -3 over 4. So I start on the left-hand side. Now on the left-hand side, I had absolute value of 7x minus 2. So absolute value of 7 multiplied by x minus 3 over 4 and minus 2. Okay, so this one, you will type it in on your calculator. This is absolute value of minus 21 over 4 minus 2. And this one is over 1. So this is minus 29 over 4, if I've done that correctly. So that's 8. Yes, okay. And this is just equal to 29 over 4. So that's your left-hand side. Then you have to do the same thing on the right-hand side. On the right-hand side, I had 3 times x, which is minus 3 over 4, minus 5. Okay, so you multiply this out. This is negative 9 over 4 minus 5. Okay, so even without actually working out what 9 over 4 minus 5 is, I can already tell they will not be equal, because on the right hand side I'll end up with a negative number, and on the left hand side what I have is positive. So it is negative 29 over 4, but on the left hand side I had positive 29 over 4. Okay, so then I conclude left hand side is not equal to the right hand side. Therefore x, which is equal to minus 3 over 4, is not a solution. Then we do the same thing with x is equal to 7 over 10. We need to check if this is a valid solution. So we substitute it in the left hand side. On the left hand side, we have absolute value of 7 times 7 over 10 minus 2. Okay, this is absolute value of 49 over 10 minus 2. This is absolute value of 29 over 10. And this is just equal to 29 over 10. Then on the right hand side, we have 3 times x, which is 7 over 10, minus 5. Okay, so here I have 21 over 10 minus 5. And this is equal to negative 29 over 10. Right, so again, we compare our left-hand side, 29 over 10, with the right-hand side, negative 29 over 10. Those two are obviously not equal. Then I make a conclusion. Left-hand side is not equal to the right hand side. Therefore, x, which is equal to 7 over 10, is invalid. So that means this equation that we were asked to solve, where is it? Over here. It has no solutions. Is it not this one? Sorry. Where is it? It's over here. So this one over here, it has no solution. So it is possible to get an absolute value equation that has no solutions. All right. Then today what we are doing, we move on to the next part of the chapter, and that is on quadratic equations. Now we have done quadratic equations before. We solved them by factorizing, completing the square, and you know the quadratic formula. So we're going to use all of those techniques and then take it a bit further. Okay, so the quadratic formula, if you remember, this is if you have a quadratic equation, ax squared plus bx plus c is equal to 0 in standard form. This is called standard form. You can actually make x the subject of the formula by completing the square. Okay, so to do that, what we do is first I will divide throughout by the coefficient of x squared, which is the a over there. So when I divide by a, what I get is x squared plus b over a x plus c over a, and this is equal to 0. If this was a quadratic expression where I do not have the equal to sign, I would then have to factorize. I cannot divide an expression because you must do the same thing on one side as you do on the other side. With an expression, you have only one side, but with an equation, you can divide both sides and not have changed anything. Then, if you remember what we did when we were completing the square, we said when we want to complete the square, the middle term will be half of the square root of the constant. Okay, so I hope I'm saying that right, but you remember how we did it. So here we'll say x squared plus b over a x. Now to find out what is missing over here, because I need to add something in order to have my square complete. To find out what that is, I just say bx over a divided by 2 . I would say bx over a. I would divide this by 2x, and then I will square it. That's how we would do it. So this is b over a divided by 2. I get 2a, and then when I square it, this is b squared over 4a squared. Okay, so that is the term you are going to put over there. Okay, so you're going to add it and also subtract it. I know some of you will just complete the square without adding or subtracting, like you skipped some steps, but we're doing exactly the same thing. So if you remember how we did it, go ahead and do it in that way. So let me just write it here so I have more space. So I have x squared plus b over a x. Then what I do is I add b squared over 4a squared, and then I subtract b squared over 4a squared, and then this c over a and equal to 0 must still be there. Okay, then I have plus c over a, and this is all equal to 0. So you can see the only difference between what I have here and what I started with is this part in blue. Now this part in blue here is equal to 0 because I'm adding this and also subtracting it. So if the difference between two expressions is 0, there is no difference. They are the same. Then this three terms, they can be factored. They make a perfect square. So this is x plus b over 2a. And then I'm left with minus b squared over 4a squared plus c over a, and this is equal to 0. Okay, now this two here, what I can do is I can combine them so that they have the same, I can combine them to make one fraction, basically. So I have x plus b over 2a squared, and then I will have, okay, I can take them to the other side first. Now we know that when we combine fractions, the denominators must be the same, and you must always pick the lowest common multiple for your denominator. So here, this denominator is a, this one is 4a. The lowest common multiple of the two denominators is 4a squared. So if I multiply this fraction by 4a over 4a, then I will have two fractions that have the same denominator. So let me just rewrite this so I have some space. So this is minus c over a. Okay, so I said I'm going to multiply this one by 4a over 4a. Then the denominator of c over a will then become 4a squared. The two fractions will have the same denominator, then I can combine them. Okay, so what I have is this. The left hand side remains as it is. On the right hand side I have b squared over 4a squared minus 4ac over 4a squared. Now the denominators are the same. I rewrite them as one fraction. This is 4a squared. Then I have b squared minus 4ac. Okay, this is x plus b over 2a. This is squared. So remember what I am doing. I want to make x the subject of the formula. So we've done questions like this where we're changing the subject of the formula. Here x plus b over 2a squared is the subject. So to get rid of the square, I take plus or minus the square root on both sides. So if I take plus or minus the square root, I end up with x plus b over 2a. This is equal to plus or minus the square root. It's a big square root because it's the entire fraction that is under the square root. Okay, now square root is a third. Remember from your formula, from your thirds, we say that if I have this, even from indices x, the square root of x over y, this is the same as the square root of x over the square root of y. And then I'm going to use this same principle over there. I put the numerator over its own square root, under its own square root, the denominator under its own square root. And what I get is this. I have x plus b over 2a. This is equal to plus or minus the square root of b squared minus 4ac over square root of 4a squared. Now the square root of 4a squared is just 2a, because if I have 2a, okay, somebody's joining, but very late. Okay, the square root of 4a squared is 2a, because I say 2a times 2a. This is equal to 4a squared. And this is the same as 2a squared. So when I take the square root, you will see that the square root and the squared cancel, and then I will be left with 2a. So this simplifies to x plus b over 2a. I don't need the brackets. And this is equal to plus or minus the square root of b squared minus 4ac over 2a. Okay, then we still want x to be alone on the left hand side, so that means I will subtract this b over 2a on both sides. Then I'll be left with x is equal to minus b over 2a. Let's try and write that better. Minus over 2a plus or minus the square root of b squared minus 4ac over 2a. So I still have two fractions, or I have two fractions on the right hand side. The denominators are the same, because the denominator of the first one is 2a. The denominator of the second one is also 2a. So I can combine them under one big fraction. So I will have x is equal to one big fraction, 2a, and then I have minus b plus or minus the square root of b squared minus 4ac. Okay, so I'm sure you recognize this formula. This is the quadratic formula. Maybe you didn't know where it came from. It comes from completing the square. Okay, so now that you have the formula, you can always just use it. As long as your quadratic equation is in standard form, you can work out the value of x. So you should get two solutions. The first one is when you make this plus, and the second one is when you use the minus over there, because there's plus and minus there. Okay, so you should get two solutions. So let's look at some of the examples there. So we have 6x squared plus 7x minus 6 is equal to minus 3. Okay, so we're going to practice using the quadratic formula. Now remember, before you pick your A, B, and C, it must be in standard form. That means everything must be on one side, and then on the other side you must have 0. Now this one that we have here is not in standard form, so I cannot just say this is my A, B, and C. I must first put it in standard form. To put it in standard form, I will add 3 on both sides. So I have 6x squared plus 7x minus 3. This is equal to 0. Now that it's in standard form, what I will do is I will identify my A, this is 6, my B, which is 7, and my C is negative 3. Okay, so it's not just 3, it is negative 3. The sign in front of the number is part of the number itself. Then we will substitute this into our formula. We know that x is equal to negative b, so that means negative of b, which is just negative 7. Then I have plus or minus the square root of b squared, which is 7 squared, minus 4 times a, which is 6, times c, which is negative 3. Okay, you can close your bracket, and then I divide this by 2 times a. So this is negative 7 plus or minus 7 squared is 49, and then I have minus 4 times 6 times negative 3, I get 121. So plus or minus 121. And then this is divided by 2 times 6, which is 12. Now the square root of 121 is 11. So what I have is negative 7 plus or minus 11 over 12. So I have two solutions. The first one, x1, this is just negative 7 plus 11 over 12. And then my second solution, x2, just label them like that. I have minus 7 minus 11 over 12. Now for the first one, negative 7, I get 1 over 3. And then for the second one, I get minus 3 over 2. So these are your two solutions. So x is equal to 1 over 3, or x is equal to negative 3 over 2. And then you're done. Again, it's always good, substitute your equation, your solutions back into the original equation and see if they satisfy the equation. Okay, they should. If they don't, check your workings. With quadratic equations like this one, you shouldn't get any invalid solutions because there's no reason why you'd have an invalid solution. There's nothing under a square root. You're not dividing by anything. So any value you get should give you a solution. Okay, let's look at the next one. I have 2x cubed minus 5x squared. And this is equal to negative 2x. Okay, so this one doesn't look like a quadratic equation. It is cubic, in fact, but you will notice that all the terms have x in common. So there's 2x cubed minus 5x squared, and it's equal to minus 2x. So what you do, again, collect all the terms on one side. So here you will have 2x cubed minus 5x squared plus 2. This is equal to x, and this is equal to 0. Then what you do is you factor x out. So you take the x out, and you have 2x squared minus 5x plus 2, and this is equal to 0. So do not divide by x throughout and cancel it out, because you will lose one of the solutions for x. So factor it out. Then you can see over here I have a quadratic equation, so I'm going to solve that one. So this quadratic equation, 2x squared minus 5x plus 2, I will say is equal to 0. So first thing, even before that, I can see that I have two terms multiplying. I have x and then the quadratic bracket. They are multiplying, and the answer is 0. This means that either the big bracket, this one that I've written here, is equal to 0, or it means x is equal to 0. So again, when two terms are multiplying and the answer is 0, it means one of them must be 0. It's a must. Okay, then this one is already solved because I know the value of x. It's just this one that is left for me to solve. So I solved that one. I use the quadratic formula. It's already in standard form. So I just need to say a is 2 b is -5. Remember, the sign in front of the number goes with the number, and c is equal to 2. Then you just substitute them into your equation. So we have x is equal to minus b. So that's negative of -5. It doesn't mean negative b is a negative number. Negative b just means multiply b by -1. Then I have plus or minus the square root b squared. This is -5 squared. And then I say minus, this won't fit, so let me just write it here, minus 4 times a, which is 2, and then times c, which is 2. And this is all divided by 2 times a, which is equal to 2. Okay, so all this and that is under the square root. So when you write it, please write it nicely. Okay. Then we continue, we get x is equal to negative of -5, that is just positive 5. Then I have plus or minus 25 minus 16, that is equal to 9. So that's the square root of 9. And then I have 4 in the denominator. So I will get x is equal to 5 plus 3 over 4, or x is equal to 5 minus 3 over 4. So this is 8 divided by 4, which is equal to 2. And this one is 2 divided by 4, which is equal to 1/2. So I can write down my 3 solutions. So finally, x is equal to 0. Remember this 0 that we did at the beginning over here. Don't forget it. It is also a solution. And or x is equal to 2. That's this one over here. Or x is equal to 1/2. Now if I had divided by x over here, if I divided by x, divide by x, divide by x, divide by x, and then cancel the x out, you will see that I will only have ended up with these 2 solutions over there, and that is not correct. So do not divide by x, rather factorize it out. Okay. And number 3, we have theta plus 6 over 4. This is equal to 2 over theta minus 1. Okay, so to solve this one, remember we don't like our fractions, so we don't like fractions. We always try and get rid of them. Now theta, you've seen it in trigonometry, it's used to represent angles, but it's a Greek letter. It's a variable. You treat it the same way you do any other variable. So what you do is we want to get rid of the denominator. So you will multiply by the lowest common multiple of the 2 denominators. So which is 4 times theta minus 1, or cross multiply as you like saying. So when I do that, I will end up with theta plus 6, theta minus 1. This is equal to 8. Okay, then we multiply out the brackets. So from here, I'm not going to do this. So please don't let me see this in the test. I'm not going to say theta plus 6 is equal to 8 or theta minus 1 is equal to 8. This is wrong. The reason it is wrong is because just because 2 numbers are multiplying and the answer is 8, it doesn't mean one of the numbers is 8. For example, 2 times 4, the answer is 8, but 2 is not equal to 8 and 4 is not equal to 8. So please don't let me see that in the test. What you do instead is you will multiply the bracket out like that, and then bring everything to one side, have it in standard form. So theta times theta, I will get theta squared. Theta times minus 1, that is minus theta. 6 times theta is 6 theta. And then 6 times minus 1, this is minus 6. And then when I subtract 8 on both sides, I will get equal to 0. Okay, so you combine your like terms. How many theta squareds do you have? It's just 1. How many thetas? I have 5 thetas. And then this is minus 14. Okay, then what you do, it is now in standard form. You just need to identify your A, B, and C. So A is 1 because the coefficient of theta squared is 1. B is 5. C is minus 14. Okay, then substitute them into the equation. Remember, we're solving for theta, so I must see theta is equal to negative b, which is negative 5, plus or minus the square root b squared, which is 5 squared, minus 4 times a, which is 1, times c, which is negative 14. And then this is all being divided by 2 times a. Okay, so here I have negative 5 plus or minus 5 squared minus 4. I get 81. And this is all over 2. Okay, the square root of 81 is 9. So I will have theta is equal to negative 5 plus 9 over 2, or theta is equal to negative 5 minus 9 over 2. Negative 5 plus 9, that is 4. 4 divided by 2, this is equal to 2. Negative 5 minus 9, that is negative 14, divided by 2 is negative 7. So it's always good to conclude with a sentence. Therefore, theta is equal to 2, or theta is equal to negative 7. And then you are done. Number 4, we have x over 7 minus 3 over x minus 3. This is equal to negative 2 over 7. Okay, so again, we want to get rid of the denominator. So what we will do is we'll multiply all the terms by 7 and then also by x minus 3 so that all the denominators are gone. So when we do that, we will have x times x minus 3 minus 3 times 7, and this is equal to minus 2x minus 3. So we know how to get rid of the denominators. Go ahead and do that. Multiply by the lowest common multiple of your denominators, which is 7, and x minus 3, and that is what you should end up with. Then you simplify, excuse me, simplify as far as possible. So I have x squared minus 3x minus 21. This is equal to minus 2x plus 6. Okay, so you multiply the way we always do. Just multiply like that. Okay, Then you want your equation to be in standard form. So what you do is you bring everything to one side and then leave 0 on the other side. So I will have x squared, and then I will have minus x minus 27, and this is equal to 0. So I have added 2x on both sides, that's why I have minus x left, and then I have subtracted 6 on both sides, that's where I got the minus 27 from. Then it's in standard form, just have to identify your a, b, and c. A is the coefficient of x squared, which is 1. B is the coefficient of x, it's negative 1. The sign in front of the number should go with the number. And c is negative 27. Okay, so I have my a, b, and c. All I need to do now is substitute into the formula. So I will have x, this is negative b, so it's negative of negative 1. So negative of negative 1 plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a, which is 1, and then times negative 27. Then you go ahead and close your bracket. Then divide this by 2 times a. So negative of negative 1, this is just positive 1. Then plus or minus, work out what you have under the square root. You get square root of 109. Okay, you divide this by 2. So this means that x is equal to 1 plus the square root of 109 over 2, or x is equal to 1 minus the square root of 109 over 2. Then you can leave each of them to 3 decimal places like you're always told on the paper. For the first one, we get 5.720. So this is to 3 decimal places. And then for the second one, we get negative 4.720. Again, this is to 3 decimal places, and then you are done. So your solutions are not always going to be integers. It is possible to have a surd. So if in the question it says the exact value, this one is the exact value. Okay, and then this one is approximated to 3 decimal places. So just follow the instructions that are given in the question. And then number 5, we have x squared minus 2a x plus 1, and this is equal to 1. Okay, now this one is different in that we have an a over there. Okay, so we still work it out in the same way. Write it in standard form. Remember, standard form, I must see x squared with its coefficient, x with its coefficient, and then c, which doesn't have x. Can have anything else, but the variable we're interested in here is x. So we'll treat a as a constant. So we will multiply this out the way we always multiply out, and then this one we will subtract it on both sides. So I have x squared minus 2ax minus 2a minus 1. This is equal to 0. Then I have to identify my a, b, and c. So it might seem a little confusing because a is in the equation, but the a I'm talking about here is the a which is the coefficient of x squared. So the a, this is 1, my b is negative 2a, so it's the coefficient of x, whatever you have in front of x, it's minus 2a, and then my c is negative 2a minus 1. So the whole of this is a constant because it does not have x attached to it. Okay, then I would substitute them into the equation the way we normally do. So I don't have much space here, but I will try and write it as far as possible, as much as possible. So here we will say that x is equal to minus b. So this is negative of negative 2a. And then plus or minus, I'll put the big square root here. And then I have b squared, which is minus 2a squared minus 4 times a, which is 1, and then times c, which is negative 2a minus 1. And remember, this is all under 2 times a, like that. So this square root that I have over here should be there in its usual place. And then this 2 times 1, that is the usual denominator. Okay, then we simplify. This is equal to 2a plus or minus. Let me see if it can fit in my square root there. So this one here, negative 2a squared, that is just 4a squared. And then I have negative 4 2a minus 1. Okay, so I'm trying to do step by step like that. Okay, so I still have to multiply the 4 into the bracket. All right, then I continue. This is 2a plus or minus. I have 4a squared minus 8a. It's plus because it's a negative. So here it's a negative, and that negative, it will give me positive. So it is positive 8a, and then I have positive 4. Okay, then I'm still dividing by 2. Okay, then what's under my square root? I see that 4 is a common factor, so I can factorize the 4 out. So I have 2a. Okay, so this is 2a. Then I have plus or minus the square root of 4. I have a squared plus, not 4, it's 2a plus 1. Like that. Then I divide this by 2. Okay, so I factorized a 4 out. Then my bracket, this one that I have over here, you can see that I can factorize it and it is a perfect square. So what I have is actually this 2a plus or minus the square root of 4. This is a plus 1 squared. This is all being divided by 2. So you know how to factorize this a squared plus 2a plus 1. You look for two numbers. When you multiply them, the answer is 1. When you add them, the answer is 2. So it's 1 and 1. So I will have a plus 1 times a plus 1, which is a plus 1 squared. That's where I got that from. Right. And then I have a product under the square root. So this is a product. It's 4 times a bracket. when you have a product under the square root, you can always say it is the square root of the individual products. So this is the same as 2a plus or minus the square root of 4 times the square root of a plus 1 squared. This is still over 2. Now the square root of 4 is 2, and the square root of a plus 1 squared is just a plus 1. So those two will cancel each other out because they're opposite operations. So what I have here is 2a plus or minus 2 times a plus 1. Then I divide this over 2. Then the 2 here will multiply inside. I will have 2a plus or minus 2a plus 2. The reason I'm putting it in brackets is to show that I will add the entire thing and also subtract it. Because if I do not write it when I'm subtracting, you might end up only subtracting the 2a and not the 2. Okay, so this is over 2. And then this, we're solving for x. So that means x is equal to 2a plus 2a plus 2 over 2, or x is equal to 2a minus 2a plus 2 over 2. Now with the plus over here, the brackets don't really change anything. But with the minus, the brackets are important because you'll multiply like that and you'll end up with negative 2. Okay, here you'll still have positive 2, so the brackets don't matter. Then I solve for the first one. I get x is equal to 4a plus 2 over 2. And this is just 2a plus 1. And then the second one, I get x is equal to 2a minus 2a minus 2 over 2. So you can see these two will cancel each other out. And then I will have negative 2 over 2, which is equal to negative 1. So my two solutions, x is equal to 2a plus 1, or x is equal to minus 1. That is how you would do it. So it's possible to get a quadratic equation where you have other constants that are represented with a letter. So it's not just going to be numbers. And you can see over here, I was able to solve it using the quadratic formula. Okay. Then 4.2.2, we look at equations containing square roots. We have x minus 2 is equal to the square root of 2x minus 1. Okay, now when you have a square roots, what you need to do is try and get rid of them. And we get rid of square roots by squaring both sides. So you will square both sides. You might end up with a quadratic equation. You solve it, but then it is very important that you check your solutions, because you know that under a square root you cannot have negative numbers there. So we do not have real solutions when we have negative numbers under our square root. So it's very important that you check your solutions, like we were doing with the absolute values. So first thing we want to do is get rid of the square root, and we say to do that we will square both sides. So I will have x minus 2 squared. This is equal to the square root of 2x minus 1 squared. And the square root and the squared will cancel each other out, Then I have x minus 2 squared. This is equal to 2x minus 1. Then I multiply out my brackets, so I'm not going to say this. I'm not going to say x minus 2 is equal to 2x minus 1, or x minus 2 is equal to 2x minus 1, or something like that. No, or plus or the negative of that. I'm not going to do that. That is equal. That is wrong. Okay, so we only do that when what you have on the other side is equal to 0. So remember that it is very important. If two numbers or two terms are multiplying, here it's x minus 2 multiplying by itself. So it's two terms. So you do not say one of them must be equal to 2x minus 1. That is not true. That is true only for 0. Okay, so to do that, we have to multiply out the brackets. So this is x minus 2, x minus 2. This is 2x minus 1. You know how to multiply out our brackets. So you have x squared minus 2x minus 2x plus 4. This is equal to 2x minus 1. Okay. Then we have x squared minus 4x plus 4. This is equal to 2x minus 1. Then you can subtract 2x on both sides. You get x squared minus 6x. And then you add 1 on both sides. That's 5. This is equal to 0. Now you can choose any of the three methods that we have done to solve this. You can complete the square, you can factorize if it is possible, or you can use the formula. So when you are not given any restrictions, it is up to you to choose. So this one can be factorized, so I will choose to factorize it. I'm looking for two numbers that multiply to give me 5, and when I add them, the two numbers should give me negative 6. So that is negative 5 and negative 1. So factorize, this is x minus 1, x minus 5, and this is equal to 0. Now, because it is equal to 0, now I can say x minus 1 is equal to 0, and this means that x is equal to 1, or x minus 5 is equal to 0, which means x is equal to 5. So these are the two solutions that I have got. What I need to do now is check if they are indeed solutions. Are they both valid? So to do the check, I will substitute them back into the original equation. So I substitute, let me start with x is equal to 1. I substitute that on the left hand side. Now on the left hand side I have x minus 2. So this will be 1 minus 2, and then this is equal to negative 1. And then on the right hand side I have the square root of 2 times x minus 1. This is the square root of 2 minus 1, which is just the square root of 1, and then this is equal to 1. Then comparing my left hand side over here with the right hand side, these two are not equal. So left hand side is equal to right hand side, and therefore x, which is equal to 1, is not a solution. Or is invalid. So you say something like that. Then you try it with x is equal to 5. Now when x is equal to 5, you substitute on the left hand side. On the left hand side you have x minus 2. So this is 5 minus 2, and this is equal to 3. And then on the right hand side, you have the square root of 2 times x, which is 5, minus 1. So this is the square root of 10 minus 1, the square root of 9. This is equal to 3. So my left hand side is 3, my right hand side is 3. Therefore, or since the left hand side is equal to the right hand side, x equal to 5 is valid, or it is a solution. That's it. So you need to check your work and see if it is correct. Do not just give me x is equal to 1 and x is equal to 5 and I must decide whether both or one of them or neither of them is valid. So you need to check and make sure that they are valid. Okay, so you can say x is equal to 5 is the only solution. Number 2, we have 6 minus the square root of x plus 2. This is equal to x plus 2. All right, so again here, like we were doing with the absolute values, isolate the square root by itself. Don't just square both sides immediately. You may make your work more difficult, because if I were to square both sides, there's nothing wrong with that. I'll put it in green to show it's not wrong, but you'll end up with this 6 plus the square root of x plus 2 squared. This is equal to x plus 2 squared. And then when you multiply out the bracket, it is this 6 plus the square root of x plus 2 multiplied by 6 plus the square root of x plus 2, and then the 6 like that should multiply this, and that will multiply like that. The square root will still be there in your calculations, so you will still have to square again, which is a lot of work. So what you should do instead excuse me, is isolate the square root by itself. So I have negative square root of x plus 2, and this is equal to x minus 4. So what I did is I subtracted 6 on both sides. Now that our square root is alone, its sign is negative, but the negative sign doesn't affect anything when we square both sides. Now I can square both sides. So I will have this x plus 2 squared. This is equal to x minus 4 squared. Then we know that when we square anything negative, our answer is always positive. So the square root and the squared will cancel, and then what I have is positive. Okay, and then on the right hand side, I will end up with x squared minus 8x plus 16. Okay, so you write the two brackets next to each other. X minus 4 times x minus 4. X times x times minus 4, minus 4 times x, and then minus 4 times minus 4. You should end up with that one there. Then we rewrite this in standard form. So what I will do is write it like this, x squared, and then I will subtract x on both sides, so I'll end up with negative 9x, and then I will also subtract 2 on both sides, and I will end up with 14, and this is equal to 0. Now that it's in standard form and it can be factorized, I go ahead and factorize it. So I put my x and my x, I look for two numbers. When I multiply them, the answer is 14, and when I add them, the answer is negative 9. So those two numbers are negative 7 and negative 2. Now, because these two brackets are multiplying and the answer is 0, it means the first bracket is equal to 0, or the second bracket is equal to 0. And if x minus 7 is equal to 0, this means x is equal to 7. And this one means x is equal to 2. And as always, you need to check your solutions. Make sure that they are valid. So we will start with x is equal to 7. And when x is equal to 7, yes?
I'm lost somewhere. What is that 6?
Which 6?
It was in the first step of the equation. Oh, now I got it.
Okay.
You took it to this side, man.
Okay. Then
Yeah,
the
I got
left-hand
it.
side, what I do is I substitute x is equal to 7 on the left-hand side. So I have my left-hand side. I will say, what do I have on the left-hand side? I have 6 minus the square root of x plus 2. Okay, then this is equal to 6 minus the square root of 9. This is 6 minus 3, and this is equal to 3. Okay, so that's what I have on the left hand side. Then on the right hand side, I have x plus 2. My x is 7, so I have 7 plus 2. 7 plus 2 is equal to 9. These two are definitely not equal, so it means x is equal to 7 is not valid. And then I do the same thing with x is equal to 2. When x is equal to 2, on the left hand side I have 6 minus the square root of 2 plus 2. This is equal to 6 minus the square root of 4. This is equal to 6 minus 2, and this is just equal to 4. So I have 4 on the left hand side. Now I need to check on the right hand side. On the right hand side I have x plus 2, so that's just 2 plus 2. This is equal to 4. Then comparing the left hand side and the right hand side, you can see that the left hand side is equal to the right hand side. Therefore, x equal to 2 is a solution. Okay, so that's how we would do that one. Okay, do we have any other questions before we continue? Okay, if there are no questions, there are some examples there in your notes, so I'll just write them here. I will give you just a few minutes, you try one, then we'll do it together and then we'll continue in that manner because I do not want to speak for the entire 2 hours. Okay, so let's see the first one. How many questions do we have? We have 15 questions. I think we can do them in 30 minutes. So here is question 1. And we have 4 over y plus 2, and this is equal to y minus 7 over negative 2. So 3 minutes, can you please try that one? Let's see what you get. you must always check if your solution is correct or not, or if it's valid or not. That's what I mean. And I think I said that yesterday as well. Always check. I want to see that you have checked. Okay, I hope you are done and we can now do it together. So it's important that you try, then you see how we do it together, because you're gauging, are you understanding? Because if you're just sitting there passively, just copying everything I do, you probably will not learn very much. So try and do the exercises by yourself as well. So here you'll multiply out the denominators. So we'll have negative 4 times 2, or negative 2 times 4, and this is y minus 7, y plus 2, like that. Okay, then this is negative 8, then multiply out your brackets. So I have y squared minus 7y plus 2y minus 14. Okay, so 7 times y is y squared, y times 2 is 2y, negative 7 times y is 7y, and then negative 7 times 2 is 14y. Then you collect all the terms on one side, have 0 on the other side. So you have y squared minus 5y. And then I will have negative 6. This is equal to 0, because I have minus 14 plus 8. Then this one, can it be factorized? Look for two numbers that you multiply them. Answer is negative 6. And when you add them, the answer is negative 5. And those two numbers are negative 6 and positive 1. So you'll have here y minus 6, y plus 1. This is equal to 0. And then y minus 6 is equal to 0. This means that y is equal to 6. And then y plus 1 is equal to 0. And then this means that y is equal to minus 1. So those are your two solutions. So I'm not going to do the checking, but you must do the checking. Check, substitute your answers back into the original equation. The original equation is over here, this one. And then you check and see if the solutions are valid or not. So the next one, let's move on. Do as many as we possibly can. The second one, number 2, we have k squared minus 9. This is equal to 0. So again, 3 minutes, quickly check. Make sure you have your working for when you checked. So it must be there. Show me that you have checked that it is valid or not valid.
Miss,
Yes.
I'm done, but I want to ask something about the yesterday recording.
Yes.
Mm, did you post it at the e-learning?
Yes, that's what I always do.
Oh, but we experienced a problem of not reaching that side of the e-learning.
Well, that's where it is. It is on e-learning.
Mm.
Okay,
Do you have the
so
link?
yeah,
Do you have the link on for the YouTube?
yes, it's on e-learning.
Okay.
Yes. Okay, so this one is very simple to do because you can factorize this using a difference of squares. So you have k squared minus 3 squared is equal to 0. So when you factorize this, this is x minus 3, x plus 3. Remember how we factorize the difference of squares? You put the first one, k, there, then the second one, 3 there, and then one is positive and the other one is negative. So this means that k minus 3 is equal to 0, or k plus 3 is equal to 0. If k minus 3 is equal to 0, this means that k is equal to 3, and this means that k is equal to minus 3. So again, you must check. So this is extra that you must do. You must check, substitute them, and this is a very simple substitution that I'm sure you do not have a problem with. Then number 3, we have the square root of x plus 5, and this is equal to x minus 1. So again, 3 minutes on the clock. Let us solve this one. Okay. With this one, we said when you have a square root, try and isolate the square root on one side and then you square both sides. So I will have the square root of x plus 5, and then I square this, and this is equal to x minus 1 squared. Okay, then this leaves me with x plus 5, and this is equal to x squared minus 2x plus 1. So I've multiplied it out. I hope that is what you also got. And then what you do is you collect everything on one side. You'll have x squared. Then when you subtract x on both sides, you have minus 3x. And then subtract 5 on both sides. You should end up with minus 4. This is equal to 0. So what you want to do is look for two numbers that multiply to give negative 4 and add up to give negative 3. So those two numbers are negative 4 and positive 1. So you put your x, then we said it is negative 4 and positive 1. Okay, then I say x minus 4 is equal to 0, or x plus 1 is equal to 0. This means that x is equal to 4, and this means that x is equal to minus 1. Okay, then you need to check your solutions, and if you do that, you should see that this one is invalid. Okay, so make sure you check your solutions. It is very important. You must check with an exclamation mark. Then another one to do. Number 4. Okay, this one should be very simple. So 2.5 minutes, I think that's enough. Minus b cubed plus 4b. This is equal to minus 3b squared. Can you solve this for b? Okay, I think we should be done. Just 30 more seconds. So again, it's very important that you do the questions yourself, because in that way you're testing your understanding. Do you really know how to work the questions out? Because sitting passively and just watching me do the questions doesn't help you in any way. You need to practice. So with this one, similar to an example that we did, we must collect all the terms on one side, 0 on the other side. So I will rewrite this as b to the power of 3 minus 3b squared minus 4b. And this is equal to 0. Okay, then I can factor out b because b is a common factor. So I have b squared minus 3b minus 4, and this is equal to 0. And then my bracket can also be factorized. So I have b. I look for two numbers that multiply to give me negative 4 and add up to give me 3. That's negative 4 and positive 1. So I put b there. Then I put negative 4 and positive 1. Okay, then my three brackets are multiplying and the answer is 0. It means b is equal to 0. The first factor is 0. Or b minus 4, the second factor is 0. Or b plus 1 is equal to 0. So for the second one, this means that b is equal to 4. And then for the third one, this means that b is equal to minus 1. And then, as usual, you need to check your solutions. Very important. Check if all of them are valid. So in this case, you should get that all are valid. Okay? But you always need to check. Then the next one, okay? When we have a square root, the idea is still the same. So go ahead and solve that one. Okay, should be done. With this one here, because the square root is already isolated by itself, you can just go ahead and square both sides. So you will get 2x plus 3 squared. This is equal to 3x squared plus 2. Okay, multiply out the brackets. This is 2x plus 3 times 2x plus 3. This is 3x squared plus 2. Then this 2 multiply, you get 4x squared. Those 2 multiply, you get 6x. You get 6x. You get 9. And this is equal to 3x squared plus 2. Okay, you can simplify the left-hand side before you combine what was on the right-hand side. So you have 4x squared plus 12x plus 9. This is equal to 3x squared plus 2. Plus 2. Okay, then you subtract 3x on both sides. You have x squared, and the 12 will stay as it is. And then you can subtract 2 on both sides. Right, so this one cannot be factorized. So what you can do is use the quadratic formula. So we know that A is 1, B is 12, and C is 7. Then you just substitute. You'll get x is equal to negative b, which is negative 12, plus or minus the square root of b squared, which is 12 squared, minus 4 times a, then times c. And this is all divided by 2 times a, which is 1. Okay, so this one you'll do it on your calculator. So you get x is equal to negative 12 plus or minus. You have 12 squared minus 4, and then you get 116. And this is divided by 2. So you'll have x is equal to negative 12 plus the square root of 116 divided by 2. So again, this you just do on your calculator. If you leave it to 3 decimal places, you get negative 0.615. This is to 3 decimal places. So depending on what the question says, if it says exact, you can just simplify the surd that you have over there. Or x is equal to negative 12 minus the square root of 116 over 2. So this, again, you just type it in on your calculator, and you should get negative 11.385. Okay, that is to 3 decimal places. And then you are done. Okay, I think we have time to do just one more question. Okay, number 6, I think it's easy, so I'll leave that one to you as homework. So all the questions that I do not manage to do, please make sure you go and do them homework. This is under 4.2.2, so I'm doing those exercises. When you go through it, you'll know which ones I did, and those I didn't do should do them for homework. So number 6, I said I'll skip it. We'll do that one at home. Then number 7, let's look at that one. We have 9x to the power of 4 plus 1. This is equal to 10 to the power of x squared. Can you try and solve this one? In fact, I think we have time for 2 more questions. Okay, I hope you figured this out, that this is actually a quadratic equation, or it's reducible to quadratic form. So if you cannot see it right away, what you can do is use the substitution that we did in logarithms. So you can let y equal to x squared. Then this means that y squared is just x squared squared, which is x to the power of 4. Okay, then you'll substitute your x squared and x to the power of 4. So you'll see this one over here, x to the power 4. I will put y squared instead. Here, x squared, I will put y instead. So when I do that, what I have is 9y squared plus 1. This is equal to 10y. And then you collect all the terms on one side, 0 on the other side. You have 9y squared minus 10y plus 1. This is equal to 0. And this can be factorized because you're looking for two numbers that multiply to give me 9. And when I add them, they give me negative 10. So it's negative 9 and negative 1. So you open your brackets as usual. This is equal to 0. Then you put your y, you say it's negative 9 and negative 1. Now the coefficient of y squared is 9. So what you'll do is you'll divide this by 9, divide this by 9. With the others, I didn't do that because the coefficient of the x squared or whatever I was squaring there was 1. So it didn't matter whether I divided by 1 or not. But when the coefficient is anything else except 1, so even if it's minus 1, that is what you should do. Okay, then you simplify your fractions as far as possible. This is y minus 1. And then here I have y minus 1 over 9 is 0. Then because we do not like fractions, what we do is we take this 9 and we write it over there. It becomes the coefficient of the y. So this is, again, it's a technique of factorizing. So we have y minus 1, and then I have 9y minus 1. This is equal to 0. And because the two are multiplying, the answer is equal to 0. It means the first one, y minus 1, is equal to 0. And this means that y is equal to 1. Or it means the second one. Or it means 9y minus 1 is equal to 0. And if 9y minus 1 is equal to 0, this means that y is equal to 1 over 9. Okay, now you need to remember you are not done. You've told me the value of y, but there was no y in the original equation. So what you need to do is go back and unsubstitute what you have over here. You said y is equal to x squared. So wherever you have y, you are going to put x squared. So this one is x squared. This one is x squared. Right, so you have this x squared is equal to 1. That's the first one over here. And then for the second one, you have x squared is equal to 1 over 9. Now, if x squared is equal to 1, this means that x is equal to plus or minus 1. And then if x squared is equal to 1 over 9, this means that x is equal to plus or minus 1 over 3. So you have 4 solutions here. So x is equal to 1, or x is equal to minus 1, x is equal to 1 over 3, x is equal to minus 1 over 3. And again, very important, the thing that we must never forget, to check your solutions and see if it is indeed correct. Okay, so I think time is up. The other solutions are in the notes. The other questions are in the notes, so please go and try them. We did about 6 or 7. How many we did? We did 6 of them. So there is 9 left. These are all for you to practice. Check your solutions. Number 14 and 15 are quite interesting. They're a little bit different, but you just need to think about them a little bit and then see if you're able to figure them out. Okay, if we don't have any questions or comments, I will see you guys next week.